Hello to all, welcome in my YouTube channel. Today I am here with class 8 new topic natural phenomena. In the previous class, we have learnt about storms and cyclones. They cause a lot of damage to human life and property. We can protect ourselves from these destructive phenomena to some extent. In this chapter, we shall discuss two other destructive natural phenomena, that is lightning and earthquake. You might have seen electric spark on an electric pole when wires become might have seen electric sparks on an electric pole when wire becomes loose or when a plug is loose in the socket. Sometimes we notice flashes of light all over the sky during rain and thunderstorms. This natural phenomena is called lightning. Lightning is an electric spark but on a huge scale, as you can see in this picture. For this we can conduct a small activity. What is required? A plastic comb. Bring it near small pieces of paper. The comb does not attract them. Now rub the same plastic comb on your dry hair and then bring it near the paper pieces. The plastic comb attracts them because it gets electrically charged. Comb, pieces of paper, a comb rubbed with hair, comb attracts the paper pieces. Similarly, when you rub an inflated balloon with a woolen material and place it against a wall, the balloon sticks to the wall. Rubbing a comb against dry hair or rubbing a balloon against a woolen material produces a kind of force in them that can attract as well as repel certain objects. The force is called electrostatic force. The comb and balloon are said to be electrically charged when they are rubbed against dry hair or a woolen material, as they acquire electric charges. So, an object having electrical charge on it is called a charged object. Now, critical thinking. The process of giving electrical charge to an object is called charging the object, while charging an object by rubbing it with another object is called charging by friction. There are two kinds of electric charges, positive and negative. The electric charge on a glass rod when it is rubbed with a silk cloth is considered positive, while the electric charge on an ebonite rod when rubbed with fur or wool is considered negative. Benjamin Franklin discovered that there are two kinds of electrical charges, positive and negative charges. Like charges repel and unlike charges attract each other. All activity can be conducted to show that like charges repel each other. For this, two glass rod, two ebonite rod, a piece of silk cloth, a piece of fur, a wooden stand and a piece of silk thread is required. We have to rub a glass rod with a piece of silk and suspend it with a silk thread to a stand as shown in the figure. Here you can see this is the metallic stand and here is the charged glass rod is brought close. The charged glass rod moves away. Okay. Now bring another glass rod rubbed with a silk cloth near the suspended rod. You will observe that the suspended glass rod moves away from the other glass rod. In this case, both the rods are of the same material, that is the glass, and both of them are rubbed with silk cloth. So their electric charges are of the same type and they repel each other. Now what we have to do? We have to take an ebonite rod with fur and hang it with a silk thread to a stand. Now rub another ebonite rod with fur and bring it close to the suspended charged ebonite rod. What you will observe that both the ebonite rod moves away from the other. Why does this happen? Because they develop same kind of charges and they start repelling each other. In this way we can conclude that like charges repel each other. Now The another activity, unlike charges attract each other. For this, a glass rod, a piece of silk cloth, a wooden stand, a piece of silk thread, an ebonite rod, and a piece of fur is required. We have to suspend the glass rod rubbed with silk cloth to a stand using a silk thread. Now bring an ebonite rod rubbed with fur near the suspended glass rod. As you can see here in the picture, one rod is rubbed with silk cloth and another is rubbed with. We can observe that the suspended glass rod gets attracted towards the ebonite rod. Why does this happen? Because the two rods of different material, one is ebonite and another one is glass, and they were rubbed with different materials, fur and silk, so their electrical charges must be different, and they show the phenomena of attraction. In this way we can conclude that unlike charges attract each other. Repulsion is the sure test of electrification, because attraction by a charged object does not indicate whether the other object being tested is charged or not. How can we test the object is charged or not? If it is attracted by both, it is not charged. If it is repelled by positively charged object, it is also positively charged. If it is repelled by a negatively charged object, it is also negatively charged. In this way we can say that repulsion is the sure test of electrification. Charges in atoms. All matter is made up of tiny particles known as atoms. An atom consists of three main particles: proton, electron and neutron. A proton carries a positive charge, while an electron carries a negative charge, and the neutron has no charge. In an atom, under normal conditions, the number of protons is equal to the number of electrons. Thus, the atom as a whole is electrically neutral. When an atom gains electrons, the number of electrons is more than that of a positively charged proton. Hence, the object is said to be negatively charged. When an atom loses electrons, there is a less number of electrons than protons. Hence, the object is said to be positively charged. Method of charging. We can do charging by friction. As we have seen in the previous activity, when a plastic comb is rubbed with dry hair, it acquires charge and attracts small pieces of paper. Charging by conduction. When an uncharged object is touched with a positively or a negatively charged object, the uncharged object also acquires the same charge as is possessed by the charged object. This process is called charging by conduction. Charging by induction. The process of charging an object by keeping it near a charged object but not touching it is called charging by induction. Of charge. To understand the concept of transfer of charge, we need to know about gold leaf experiment. An electroscope is an instrument used for detecting electrical charge and its nature on an object. It was the first electrical charge detecting instrument. First electroscope was invented by the British physician William Gilbert. It is a very sensitive and delicate instrument. In a gold leaf electroscope consists of a brass rod which passes through a rubber stopper in a glass jar. The top end of the brass rod carries a brass disc and the lower end carries two thin gold leaves such that they hang parallel to each other. The glass jar protects the gold leaf from the outside air current. The lower part of the glass jar in the interior is surrounded by metal foil. When the electroscope is used, the metal foil is earthed. This increases the sensitivity of the electroscope. Some electroscopes have strips of silver, copper, aluminium or brass instead of gold. You can see here in the picture gold leaf electroscope. Here is the brass disc, rubber stopper, glass jar, brass rod, metal foil, and this is the gold leaf. Now, why does a charged body lose its charge when touched with hand? A charged body loses its charge when touched with hand because human body is a good conductor of electricity, and when we touch the charged body, the charge is being transferred to the earth. Earthing. The process of transferring of charge from a charged object to the earth is called earthing. You can see here positively charged electroscope. Here is the brass disc touched with a glass rod, rubbed with silk. Here is the brass disc, glass jar, gold leaves diverged. And here you can see hand, brass disc, glass jar, gold leaf of electroscope collapse. Becomes uncharged electroscope representing earthing. Here you can see earthing, and this is the glass jar. Usage of gold leaf electroscope in the detection of charge. No effect on leaves, and leaves show divergence when object to be tested. Now, to identify the nature of charge. Story of lightning. In 1752, on a dark June afternoon in Philadelphia, USA, the 46-year-old Benjamin Franklin, an American scientist, decided to fly a kite. With the help of his son William, he attached his kite to a silk string tying an iron key at the other end. Next charge on the object flows. With the help of his son William, he attached his kite to a silk string, tying an iron key at the other end. Next, they tied a thin metal wire to the key and inserted the wire into a Leyden jar, a container for sorting an electric charge, a container for storing an electric charge. Finally, as the sky darkened and a thunderstorm approached, they attached a silk ribbon to the key. Holding on to the kite by the silk ribbon, Benjamin flew the kite. Once it was aloft, he went into a barn so that he could not get wet. When a storm cloud passed over Franklin's kite, the negative charges in the cloud leaked onto the kite. His kite string, his key, and the Leyden jar are tied to the key by a thin metal wire. Franklin, however, was unaffected by the electric charges because he was holding a dry silk string which insulated him from the charges on the key. When Franklin touched the key, he received a shock because the negative charges in the key were so strongly attracted to the positive charges in his body that a spark jumped from the key to his hand. Franklin's experiment successfully showed that lightning was actually static electricity. Franklin realized that this form of electricity would be charged over a conductor and passed into the ground. He invented the lightning rod and lightning conductor, providing the lightning an alternative path to the earth.